For years, Artemis 3 was the most anticipated mission in recent space exploration history, the moment humans would return to walk on the moon for the first time in over 50 years. Then, in February 2026, NASA announced that Artemis 3 would not land on the moon, and the entire world wanted to know why. And this wasn't just disappointing news for space fans. Astronauts had spent years training specifically for that landing. Engineers had dedicated entire careers to it. For millions of people watching, it felt like the dream was being quietly shelved again. The answer isn't a single obvious technical failure. It's a chain of compounding problems that no engineer can ignore when human lives are on the line. It all starts with a problem nobody has fully solved: the Orion heat shield. On Artemis 1, the shield came back with chunks broken away larger than predicted, and the computer models simply couldn't explain why. On Artemis 2, they flew with humans aboard knowing about the problem, because it was the only way to collect the data they were missing. The shield survived. The astronauts came home, but the divots came back too, and that means the problem still isn't fixed. But the heat shield is only the first problem. The second one lies in the sheer size of the rocket that needs to land on the moon. Starship is so large and burns so much fuel that it cannot reach the moon on a single tank. It needs to be refueled in orbit before it can even begin the journey. And that rocket isn't built by NASA. It's built by SpaceX. The company contracted to convert their Starship vehicle into the lunar lander that would carry astronauts to the surface. And to fill that tank in space, SpaceX would need to launch at least 14 tanker flights, one after another, before Starship could leave Earth orbit at all. This process of transferring cryogenic propellant, liquid methane and liquid oxygen, between two vehicles in zero gravity has never been done before at operational scale. Blue Origin faces the same challenge with Blue Moon. Storing and moving cryogenic fluids in orbit is a problem still being solved while the clock keeps running. Beyond the propellant, there's another invisible problem. The spacesuits astronauts will wear on the lunar surface still require critical engineering changes. The suit's oxygen tanks need to be larger to meet NASA's minimum safety requirements, and that redesign was still being incorporated into the hardware when the decision was made. So imagine stacking all of that onto a single mission: a heat shield with a history of damage, a refueling process never tested at scale, suits still in development, all of it playing out 238,000 miles from Earth with no quick way home. Aerospace engineering has one principle that never changes: you test the way you fly, and you only fly once you've tested. Putting astronauts inside a lander that has never carried humans, docked to a vehicle that has never been refueled in orbit, wearing suits that aren't yet certified, directly above the lunar surface. That is the exact definition of breaking that principle. And there's one more reason NASA couldn't afford to get this wrong. China has its own lunar program, and their stated goal is a crewed moon landing by 2030. Every delay NASA accepts narrows that margin. This isn't just an engineering decision, it's a race. So NASA didn't cancel the landing. They moved it. Artemis 3 became the test that makes sure the real landing won't fail. It's exactly what Apollo 9 did in 1969. Test the lunar module in Earth orbit before sending humans to the moon 4 months later. Without Apollo 9, Apollo 11 never happens. The actual landing was moved to Artemis 4, targeted for 2028, with every system tested, certified, and ready for the most important moment in space exploration since Apollo 17. NASA didn't give up on landing on the moon. They decided that this time, when human boots finally touch that surface, everything will work. Think about it. The last time a human being stood on the moon, it was December 1972. Everyone who watched that moment on television is now in their 70s. There are entire generations who have never seen it happen in their lifetime. Artemis isn't just a space program. For a lot of people, it's the last real chance to witness that moment in their own lifetime. And maybe that's exactly why getting it right matters more than getting it done fast. Thanks for watching. We are the Exposed Engineering. Subscribe for more.